Alright, so this is page 2 of your linear programming notes. Page 3, excuse me. Page 1 and 2 you can find on linear programming 1 and 2. This is going to be linear programming page 3 and 4 is what I'm going to call it. So at the top here we're talking about making planters. Like picture a green pot with dirt in it, and we're going to plant some flowers in there, and then we've got a purple pot with flowers in it, and we're going to plant different kind of arrangement in there. That's kind of what this type A and type B is talking about. Type A would be our green one, has 2 ivy plants and 2 mums. So I'm going to kind of underline that because that's kind of what are the main things we're talking about here. We're talking about the planters. Okay, we're talking about the planters. Type A has 2 of each. Type B though has 3 ivies and 1 mum. Okay, we'll kind of get, well, matter of fact, we could probably come right down here and start filling in some of that information. Number of ivy plants in type A is 2. Number of ivy plants in type B is 3. Number of mum plants in type A is 2. Number of mum plants here is just 1. So of course there's 4 total, but that's not what I'm talking about when I say total here. I'll get to that. Okay. Each week Mary has 24 ivy plants and 12 mum plants available, which means she has a total of 24 and 12. Which means I can use up to 20 of them, I can use 5 of them, but I can't use more than 24. So mathematically we say that that's less than or equal to 24, right? For the ivy plants. For the mum plants we have 12. Well, then the total is less than or equal to 12. There's a reason I'm doing this, I'll get to in a minute. If the profit on type A is $9, profit type A is $9, the profit of type B is $7, well, then we can put those numbers here. Okay, and that's going to give us our total profit, P. How many of each planter should she make every week to maximize their profit? So we're calling X our number of planters for A, and Y our number of planters for B. Now ordinarily you got to come up with this X and Y, but it's just the 2 main things they're talking about. We'll get to more examples here shortly. So I'm not going to put a total here. It'd be X plus Y. We're not going to use that anyway. But from this information we have to use our objective function, and our objective function 95% of the time is going to come from profit. It is always an equation, put an equal sign there, and it is P equals, right here, 9x plus 7y. Okay. Our constraints, okay, are going to be, well, the constraints are always inequalities. Okay. And by inequalities, I mean they're going to have these symbols or these symbols in them. Always are constraints. Okay? And it's given to us if you set it up in a table like this. It's given right there. 2x plus 3y is less than or equal to 24. It's that simple. 2x plus 1y is less than or equal to 12. Okay? And then we talked about in class about how everything is positive because we're not talking about negative ivies, we're not talking about negative planters, etc. So your X is going to be greater than or equal to 0, and so is your Y. And all that does really is put you in the first quadrant. We've talked about that too. Okay. Now, if you remember, we use the cover-up method here. We can cover up the first letter and solve for Y. When I divide 3 out there, I'm going to get Y to be 8. Okay. Then I'm going to do the same thing to the Y and divide that out and get X to be 12. Those will both fit on my graph, so that'll be okay. Now if I go to my other one here, sorry, I'm trying to find a different colored pen here. I can cover that up and see X is 6, and cover that up and see Y is 12. And so when I go to graph these, I know I'm going to be in the first quadrant. So down at the bottom here, let's make just the first quadrant. If you remember the first quadrant, what I mean is 1, 2, 3, 4. Everything's positive up here. So I'm just going to kind of draw those lines, the far left and the very bottom. Because now this gives me the first quadrant, right? This is the y-axis, the x-axis, okay? And we're just going to plot these points. Remember, these points are your x and y intercepts. So this is 12, 0, and this is 0, 8. This is not the point 12, 8. Same thing here. This is 6, 0, and 0, 12. Not the point 6, 12. So let's go plot the top one here. X is 12. These are 14 here. So I'm going to go here. Matter of fact, maybe 5, 10, 5, 10. So 12 is right here. 8 would be right here. And again, you're going to want a straight edge because you want to be as accurate as you possibly can be. So I just use my ID here. And again, try and get corner to corner as accurately as possible so you can see your point of intersection from there. Okay. Now, the next one, I'm going to use my other color here. I got x equals 6 right here. I got y equals 12 way up here. And, oh, I forgot to shade. I'm getting a little ahead of myself. Remember the shading, we always test this point right here, 0, 0. So if I plug in 0 here and 0 here, I get 0 is less than or equal to 24. It works, and so I'm going to shade that down. Okay, go light if you haven't already, just so you can see the other one. I'm going to put this in here. And again, I plug in 0 here and 0 here. I get 0 is less than or equal to 12. That's true. So that line also shades inward. And our final region is bounded right here. So I'll make it a little darker so you can see it. And what I need here now is the vertices. There, 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 and there. Okay. Well, this is obviously 0, 0. Let me use my other pen here, sorry. I've got 0, 8, I've got 6, 0, and I got the point of intersection here, which is over 3, up 6. Okay, it kind of works out nice. We can see it right there in the picture. Okay. Now, what always goes here is your objective function. You can see it says p, so p equals 9x plus 7y. And we're going to plug these points in to find out what our maximum is. Of course, 0 is not going to work. That's just going to give me 0. And then I've got 0 plus 56, I've got 54 plus 0, and I've got 27 plus 42, and obviously you can see 69 is the biggest number of all of them. So I should make 3 of the type A and 6 of the type B to earn $69 profit. Okay? And that's example 3. Okay, that's it. You did all this work just to come up with this answer. Okay, on the problem that I had you do last night, number 1, it was literally just 5, 0 as a solution. So sometimes you can get all of one and none of the other, but the majority of the time you're going to get a little of each. Okay, so if I don't know how to find that 0.36, if it doesn't show up as obvious as it did here, then I got to start doing some math. I'm going to show you that on the next page. But I could have done it here. If I had just times this line by -1 and cancel out the x's, I would have got the y to be 6, plugged it back in to get the x to be 3. Okay, you'll see that again on the next page. Let's go to the next page. Alright, so you're selling cases of mixed nuts and roasted peanuts. Okay, you can order no more than 500 cans and packages. Okay, so I'm going to start filling in this pack. I know that, well, the number of cases is my x and my y. Okay, how much do I need to have to be able to maximize my profit? What's my maximum profit? We'll get to that answer too. The number of units, well, it tells me right in the problem, there's 12 here and there's 20 there. And the number of units, it says right here, is no more than 500, so less than or equal to 500. Okay. The cost is in money, so obviously that's $600, and we can't spend any more than that. It cost me $24 per case there. It cost me $15 per case there. And my profit per case, now I know it says I'm selling it at $3.50. If I go $3.50 times 24, I get 42. Minus the 24 I spent is how I got to 18 here. Same thing here. 15 times 20, excuse me, $1.50 times 20 is $30. Minus $15 it cost me is how I got that profit there as well. Okay, and that's just my profit function, which again should trigger right away. That gives me 18x plus 15y is my objective function. Comes right from the profit the majority of the time. Okay. Now my constraints, again, just like the previous problem, are given right within the problem. 12x plus 20y is less than or equal to 500, and 24x plus 15y is less than or equal to 600. Let me write those down. And then, of course, x is greater than or equal to 0, y is greater than or equal to 0. So when I go to graph this, again, I'm going to stay in that first quadrant, so I'm going to use the far left. Excuse if it's not as straight as the line itself for this. I will draw my lines with a straight edge. X-axis, Y-axis, of course. And again, I need to find my X and Y intercepts. So again, for this, I'm going to divide that out. I'm going to get Y to be 25. I'm going to get X to be, well, 500 divided by 12. It doesn't come out real pretty. It's 41.6 repeating. Okay. For my other line, when I divide X out, this works out a little nicer. It's 25. When I divide the Y, 600 divided by 15, excuse me, it's 40. There's only 14 boxes here. Okay, it doesn't actually work out to go up by ones. We won't get everything in. In fact, even by twos, 2 times 14 is 28. I'm not going to fit that 40 or that 41.6 in there. But 3 times 14 is 42. So I'm going to go up by threes. So let's label that if I go by threes. So by threes. 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. The end is 42. Okay, 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. Okay, now I'm just going to go plot those points. And I tell you what, it's pretty nice to plot 41.6 because it's right next to 42. Not directly on it, but sure is close. And then 25, well again, this is 15, 18, 21, 24, 25 would be 1/3 of the way through there, just a little above that, right? And again, I'm going to use my ID here, straight that line out. My other line, again, X is 25, 18, 21, 24, 25, right about there. And Y is 40, if that's 42, 40 would be right above 39, right there. Okay. And I'm going to connect those dots. Like so. Now what I didn't do is shade again, but again, this is 0 less than or equal to 500 if I plug in 0, 0, and 0, 0 is less than or equal to 600, so they're both going to get shaded in. This one this way, this one this way. So here, again, is our solution, our region, okay, and our feasible region actually is what we want to call it. And I'm coming up with some vertices. I see one here, I see one here, here, and here. I know most of those. I know 0, 0. I can see right here is 25, 0. Right here is 0, 25. But the last one, boy, it looks like it's 15, 16 or 16, 15. It depends how accurate I was with my lines. But if I can't see it 100% exact, which, by the way, if I wanted to try 15-15 or 15-16, I could really plug it into both of these to see if it works. Okay, but if I can't see it, I'm going to take these two equations, write them down here. Okay, I've got 12x plus 20y less than or equal to 500, and this is for what I'm trying to solve now. That could be just an equal sign. I'm going to rewrite that in just a minute. Okay, I'm going to times this line by -2, like we did with elimination. This is why we did all those things, to get the x's to cancel. So I get -24x minus 40y equals -1000. Again, the equal sign doesn't matter anymore. We're just trying to solve for this point. Those cancel. That gives me -25y. That gives me -400. And y, well, is 16. So I'm going to go plug that in here. And then plug 16 into either one of these. 20 times 16 is 2 times 16 is 32 with a 0 on it. So 12x plus 320 minus the 320 to both sides and divide by 12. When I do that, I get 15. Now I have my points that I can plug into my objective function to get my answer here. 0 plus 0, of course, is 0. I'm going to go through these kind of quickly here. Here I get 450 plus 0. Here I get 375. And here I get 270 plus 240, which is 510. And there's my max, right? So I should buy 15 cases of the mix and 16 cases of the roasted for $510 profit. got a lot of stuff written there, so I'm going to circle this answer here. Okay. So, what did the question ask? How can I maximize my profit? Well, with 15 to 16. And then how much is the maximum profit? $510. We answered it all by doing all that work. Okay. So now your homework is going to be to finish 1 through 6 of the linear programming introduction. Now again, you were supposed to have already done number 1 by today. Okay, you should have that checked and hopefully ready to go. Hopefully you feel good about that. You had some time in class to work on that yesterday, and that should be okay. So you're going to do 2, 3, 4, 5, 6. Okay, I am going to help set up a couple of problems here. I'm going to kind of start number 2. So if you want to just kind of peek at what I'm doing here. Okay, for the first line again, we know x equals 6 and y equals 6. That's just from covering up, get 6, cover up, I get 6. So I'm going to go graph those two. We know how to do that. Okay. And again, use your straight edge so that you can be accurate here. Get them in the corners and then connect your dots. And I'm going to shade 0 is greater than or equal to 6. Wait a minute. 0 is not greater than or equal to 6, which means I don't shade towards 0, 0. I shade away. It's somewhere in this region here. Okay, then I've got my other 2 points. This right here is really just graphing on the x-axis everything between 0 and 8, which means I have a line here at 0 and I have another line here at 8. And they're solid because it's less than or equal to. And really what this means is I'm talking about everything that could happen in between here. Okay, everything that can happen in between there. Okay, trying to find my red pen here. For my y, so this is what I use for that. For red, again on the y-axis, this axis, everything is between 0 and 5. So I've got another line at 0, another line at 5. I'm going to shade in between there. And you can see the multi-shaded region from here. It has this point, this point, this point, and this point as its vertices. I'm going to kind of really darken that in here. Okay, you've got those vertices. Now you can use those to plug it in there and solve it. I've kind of already got you to that point. Okay, I'm going to talk about 2 more problems here. Number 4, for instance. Okay, on the next page. A lot of people have problems with this, but if I use the cover-up method and I cover up the y, excuse me, you can see, well, kind of, the x is just -1. That's right here. We haven't done that a whole lot, but it's possible. If I cover up that, the y is +1 because a negative divided by a negative. Really, this is like having a -1 there. And that is right here. And what you don't get is one of these that connect like this. They connect like this instead. Really, you can see it's going up 1 over 1. So you can see all these points that are going to be on that graph and use your straight edge to connect it. Now, you don't need all those points. Really, you just need the first 2. But if it's going up 1 over 1, you better make sure your whole line is following that pattern. Oops. You get the idea here. Straight like so. And again, if I test 0, 0, I get 0 minus 0 is 0. It's greater than or equal to -1. And that is a true statement. So this right here has to be part of the solution. So this is shaded down. Okay. You can do the other 2 lines. Keep in mind, this does not say 0. So y is greater than or equal to 2 is the line right here, shaded up here. You can see where your solution is going to be somewhere in here based on that line right there. Okay. Also, you're not going to need this last blank. It's going to end up being a triangle. Okay. If you don't get a triangle, you did something wrong. You're only going to have 3 points. Okay. Last problem for number 6. Okay. I'm going to help set up the table. If you notice, like in our notes, they gave us this table here, or they gave us this table here, and on this problem, they didn't give us a table. So I want to go through and kind of help you how to develop a table here, and then you should be able to do number 6 as well. Remember, you can just put your x and y axis right here on the bottoms, and the side. Okay. So your box is going to look something like this. Okay. I'm going to be comparing the 2 things that they're talking about here, and the 2 things they're talking about skin lotion. We've got a regular skin lotion and we got an extra rich skin lotion. So regular, extra rich. Those are going to be our categories. Okay. Then what we're talking about here is, well, the first thing we're talking about is how many of each. So number of each is just going to be our x and our y. Okay. Then, and I'm not going to fill in this information, I'm just going to tell you, the two things they're talking about within it is oil and cocoa butter. Got it matched up here for the first one, got it matched up here for the second one. Maybe we should underline, circle all of that. And it's giving you that as well. So here we're going to talk about oil, how much oil is in each one of those. We're talking about how much cocoa butter there is in each one of those. And then, of course, last but not least, we're going to talk about the profit. And remember, our objective function comes directly from that. It should be, okay, so total, I forgot to put total over here. And the reason that we need total is because it does tell us the totals, right? For this, the total is just our p. So I'll have p equals, and whatever comes here, that x plus that y, you'll figure that out. Wanted to start you with a table so you could see how easy that is, getting it right from the information. You're going to have to do that tomorrow, not today. Again, for today, you're going to do 1 through 6. I've already started 4, very detailed. Number 2, very detailed. 4, I kind of started, and 6, I gave you the box. So get to work. This is for the rest of the hour. 1 through 6 is due by tomorrow. And tomorrow, I'm going to put you in groups, or Monday, however this falls. I'm going to put you in groups to kind of finish all this. So if you don't have 1 through 6 done, you're going to look kind of foolish and you're not going to be able to participate with your group. Make sure that you get 1 through 6 accomplished. You have plenty of time today. If you watch this the whole time without pausing, it's about 22 minutes. So you still got about 40 minutes to work through 1 through 6. I do not mind if you work with other people, but I want to make sure that you understood the notes and that you got through that stuff before you get to this point. Okay? If other people that you want to work with are still watching the video when you're done, work through as much as you can, then you'll be able to contribute to the group even easier. Okay? Have a good weekend or a good day. See you tomorrow.